Have you ever wanted to build a real application with C# but every tutorial either moved too fast, skipped the important concept, or left you wondering how everything fits together? Then you are at the right place. In this course, we are going to build a real solid foundation in ASP.NET Core, the framework used to power everything from small businesses website to enterprise applications serving millions of users around the world. But this isn't going to be another course when you blindly copy-paste code. Instead, you will understand why every piece exists, how it's works behind the scene, and when to use it. We will start with the fundamentals of how ASP.NET Core work, then gradually build our way into creating REST API, working with SQL databases throughout Entity Framework Core, designing clean application architecture, implementing authentication and authorization, securing our application, handling errors, validating data, writing autonomous tests, and applying the same development principle used in professional software teams. By the end of this course, you won't just know how to build an API, you will understand how modern backend architecture are designed, structured, and maintained. Whatever your goal is to become a professional .NET developer, prepare for your first job interview, or simply build better software, this course is designed to give you the knowledge and confidence to get there. So, let's start. So, what exactly is ASP.NET is? To answer that, we first need to talk about .NET. .NET is Microsoft's modern development platform for building software. Think of it as the foundation that provides you everything your application needs to run, from executing your C# code and managing memory to giving you powerful libraries for networking, file handling, security, databases, and much more. On top of that foundation, Microsoft has built-in specialized frameworks for different types of application. Want to build a desktop software? .NET has its own framework for that. Want to build a mobile application? It has its own framework for that too. Need cloud services, background worker, or console application? Those are all parts of the same ecosystem. And if you want to build a web application or REST API, that's where ASP.NET Core comes in. ASP.NET is the web framework built on top of .NET. It gives your application the ability to receive HTTP requests, process them, execute your business logic, communicate with databases and external services, and return the response back to the client. In other words, .NET provides the platform, while ASP.NET Core provides the tool for building applications that lives on the web. One of the reasons ASP.NET Core has become so popular is for its performance. It is consistently ranked among the fastest web framework available today, making it a great choice for everything from professional projects to enterprise-scale systems handling millions of requests. It's also completely open source and fully cross-platform. Whatever you are developing on Windows, macOS, or Linux, the development experience is nearly identical, and your application can run virtually everywhere. From your local machine to Docker containers and cloud platforms like Microsoft Azure, AWS, or Google Cloud. Another major advantage is the ecosystem. Everything works together naturally. Built-in dependency injection, authentication and authorization, configuration management, logging, background service, testing, cloud deployment. These aren't separate tools stitched together by the community. They are designed to work as a complete platform, allowing you to focus on building features instead of writing infrastructure together. Throughout this course, we will explore these concepts step by step. You don't need to understand dependency injection, middleware, entity framework, authentication, or testing today. We will introduce each concept when the time is right, explain why it exists, and use it in a real project, so it becomes second nature. The only thing you should already be comfortable with are the fundamentals of C#, variable, method, classes, object, loops, collections, and the basic of object-oriented programming. If you are confident with those concepts, you are more than ready to start learning ASP.NET. And with that foundational in place, let's create our first ASP.NET Core application and see what actually happened behind the scene when your application starts. Now that you have all the prerequisites, we can get started. So open up your IDE. Could be Visual Studio Code, Cursor, Anti-Gravity, and also JetBrains IDE Rider. I personally prefer JetBrains IDE as they are actually the best IDEs for the job. This video is not sponsored by JetBrains, although I would love them to give me one. And honestly, the JetBrains IDE are kind of the best to learn to develop a real world application. So let's get started. First of all, let's open a new solution, and we will pick up the latest version, which is net 10, the latest version of the SDK. We will pick Web API, and in advanced settings, we will use controllers. We will pick that up, and let's create a Git repository for that. Next, let's change the name. So the name will be learnsp.nice. Next, let's click on create. Now let's go over the structure of that. First of all, you have the program.cs. This one serves as the application entry point to configure the server and request pipeline. The controllers folder handles incoming HTTP requests, and the weather forecast, this one, acts as a sample data model. The project environment and external package are managed through the properties right here, properties folder, and the dependency folders as well, while the application settings are stored in a JSON format right here. So this is the structure of the project, and now let's run the application. So we can just click right here on IntelliJ, and it will run our application successfully. Now if we will go ahead to localhost port 5216, so let's go there, click on that. So now if we can run our application, we can go right here in IntelliJ, have this beautiful run button and application running on port HTTP localhost port 5216. Now if we will go ahead and click on it, you will see an empty page because we didn't create any controllers or anything for that matter. So let's stop it, and now let's continue. And let's talk about dependency injection, the supply chain. Think of dependency injection as a professional supply chain for our web application. Instead of building every parts ourselves, the we ask for them at our door. It is the most powerful way to keep our application lightweight and clean. Imagine you are a chef who does not need to hunt for every ingredient. The supply chain delivers exactly what you need, exactly when you need it. Now, let's define. So, let's show you exactly why are we using dependency injection and the problem that it solves. So, if you don't remember, let's create it. So, let's add a new directory right here. Let's call it services, and right here let's add a new C# class. So, let's add, and let's call it message service. That will be responsible of sending messages in your application. You may have SMS, email, all of that stuff, and you will need to send the verification email maybe to ensure that the email of your user is actually valid. So it happens. So let's create it. So let's create a simple method. So public void. It will be just a simple send method, and it will take a string of text. Super simple, and let's just make super simple method, nothing too special. Just for the use case. In a real application, you will need to connect to your email, SMS, etc. service, and then you will need to create the actual message, blah blah. We don't actually need it now. Now let's continue, and let's create the user service when we are. Now we will have the simple register user method. So public void register user, and we will get a string for the username. username. That's all. And let's say that we need to send an email where to verify the user as we talked earlier. So we will need a message service. So let's put it as a field right here. So it will be a private read only field. It will be the message service and message service. Now let's inject it with the controller and let's use it right here. Message service to send with the username. Now this approach isn't good at all. As you can see, we have tight coupled our message service to our user service. And if we want to add any service in the future, maybe we want to change from email to SMS, to Slack, to sending through other new technology that may pop up. It will be super difficult for us. Let's say that we want to add an SMS service. So SMS service to send messages. Let's create a new method to send. So void and let's call it send SMS. Now we will only have the string for the text and we will do this same as we did in the message service right here. Now if you want to change the implementation in the user service, we will need to change it. We'll need to change it from message service to the SMS service, and right here we will need to change this as well, and this we will need to change it to SMS service and then inject it, and right here we will need to change it again to the to the message service, and we will need to use the send SMS again. So this is tedious. Imagine doing this throughout thousands files, thousands dependencies, a large application, not small ones like this, like I'm talking real deal. So this will be super difficult for us. And this is exactly why we are using dependency injection. In dependency injection, we will not talk directly to the message service. The user service will talk to an interface. An interface, if you don't remember, is a contract. It's only said what should be in a certain class and it doesn't bound, and the interface doesn't have any method in it, any actual implementation. Only the contract, only what does the class that would implement it should have. So now let's create the message service interface and let's create the send method as a contract, and then let's implement it and let's show you exactly how everything became much easier to handle. So right here, let's create a new interface. Let's put it as an interface and it will be iMessage service. Let's click and now let's define the contract, which will be void simple send method with the string for the text. So string for the text. That's all. Now let's implement it right here. So message service, let's implement. Great. Now we already implement the send method, so we can go. Now right here in the SMS service, let's implement it as well. Now we have a problem, so let's just change it, and there we have it. And now let's change the implementation to use our so instead of a concrete implementation, let's change it to use the message service. And right here, let's change security. Now let's register our services as scoped in the program.cs file. So let's enter it. And now right here in the builder, let's use builder.service.addScope. Scope, it will be for the iMessage service and for the message service as well. So we added it as a scope. And finally, we need to consume, quote unquote, our service where we actually need it. The most professional way is through the constructor is with the construction injection. We tell our controller that it is must have the service to function. ASP.NET will automatically find the supplier and deliver the service to the constructor. It is like specialized tool arriving at the workstation just as the worker started. Now let's inject the service into a controller. So let's create the controller. You don't need to know how controller works for now. This is just for the example. So let's create the welcome controller. class. Let's click. Now let's create the controller. So let's add it. Now you don't necessarily need to know how controllers works and everything like that. For now, we will go over it in a future sections. But for now, let's go with it to just showcase exactly how dependency injection works. So welcome controller. Now it will need a few things. First of all is to be inherited from the controller base. Great, and should have view. Yes, great. Now let's use the iMessage service in here. So it will be a private read-only iMessage service. So iMessage service will be for it. Next, let's inject that using the controller. So using the controller, we will inject that, and .NET will inject for us the needed service. Now let's use HTTP GET, super quick, public, action result. It will be a get, and it will return okay with the message. So it will return. It will use right here the get message method that we have defined in the message service, and we'll use it. Now right here, this is the simple method, so you will not get too confused. We have the controller right here. Controller is an opening to the outside world. To get the request, we will route it to a certain route because we will maybe want, we will route it to a certain route because we may want, because we have multiple endpoints in our application, so we need to know exactly how to get to each one of those. And right here, the HTTP get is a get method is a read method for HTTP. You will explore all of that later on. The main thing that we need to focus on is that we used right here the get method from the message service. We defined the interface, the message service, and we use it right here. And now that you have talked about dependency injection, let's talk about one more core thing that is super important to know before we start developing a great application is the configurations and middlewares that we have in ASP.NET. You can think of configuration as a professional control panel for our web application. It is where we store all of our secrets, settings, and connections string for every environment. Whether you are in a development or production, your application needs to know how to behave. Imagine a pilot in a cockpit. They do not hardcode the flight path into the engine. They use the control panel to set the destination and monitor the sensors. In ASP.NET, we use application settings. The JSON file is our primary control. It is a structured, environment-aware way to manage our building parameters. Now, let's add a custom settings to our application settings. So right here, this is the application settings.json file. And now let's add a new settings. So now let's add the settings. So right here, it will be skyline setting, and let's add those settings in a JSON format. Great. Now let's add message, and it will be welcome to ASP.NET my friend. And let's add the retry count just for fun, and it will be 3. Now, reading those strings that we have and those configuration that we defined right here directly in our code, if we will put them directly in our code, it's bad. And it's leave our application completely vulnerable to certain threats. Imagine that you have a security key that you need to have for your application. Maybe an admin password. You don't want your admin password to be in your application code. It's quite bad. Instead of that, you will want your secret safe. Now, reading a configuration string directly is like reading a raw manual every time you need to press a button. It is slow and prone to error. In professional .NET development, we use the options pattern to map the settings to a C# class. This gives us a type safety, meaning we get autocomplete and catch errors at compile time. It's like having a labeled digital dashboard instead of a pile of loose colored wire. We will start by creating a simple class that match our JSON structure exactly. So now let's create our Skyline settings class. So right here in the services, let's add a new class. It will be the Skyline settings. Let's create this class. Let's add the two fields that will mirror the ones that we have right here, which is the message and the retry count. So right here, it will be the string of message, and we will set it up to string.empty. It will be an empty string at the beginning. And let's use an integer for the retry count. Great. With our class ready, we need to tell ASP.NET how to connect the JSON to this C# object. We do this in the program.cs by binding the configuration sections to our class. This is the industry standard for managing secrets and environment-specific data. It is like plugging our dashboard into the application configuration system. Once bound, we can inject these settings anywhere in our application. Using the I option, this makes sure that our application is always configurable without changing a single line of code. Now let's bind the configuration in the program CS right here in this beautiful file. So let's add a new builder.service.configure and let's use Skyline settings. Let's close it up and use the builder configuration and let's get the sections of Skyline settings. So we configure it and we get a configuration right from here. Great. Let's switch gears to the middleware, the filter system for every incoming request. Think of a middleware as a series of checkpoints that every request must pass. Imagine a security building where every visitor is checked by security, then a recipient. If security says no, the visitor never even reach the elevator. In ASP.NET, we call this the request pipeline. It is incredibly powerful. Each piece of middleware handles one specific job, keeping our code clean and modular. Now let's create a custom login middleware using the use method. Right here in the program sys file, we will add a middleware. Right here, let's use application.use for our middleware. Now it will be async and we'll get the context and the next. Now, first of all, let's create the logger. So var for logger, and let's create the logger. So using the context dot quests service dot get required service, and let's use an ilogger of the program. Next, let's just use the logger to log the information. So log information, and let's add request, and let's use the method and the URL for it. Great. And now let's await and use the next method. Now notice that the await next, this line right here, that's the most important part of the filter system. It tells ASP.NET to pass the request to the next checkpoint in the pipeline. If we didn't call it, the request would stop right there, like a door that will not open, never. This allows us to add things like authorizations, error handling, and compression. We can even modify the response as it flows back down to the checkpoints to the user. This is how world-class professional web engineers are architectured. Now, let's add a custom header to every response. Now a header is part of the response. We will make a deep dive into it later in the REST API section. So let's just create it super fast. So app.use for the filter, and it will be asynchronous. so asynchronous with the context and the next. So let's go ahead and let's add a new header. Let's use the context dot response this time, response, and let's use the headers and let's append a new header. So this will be the, let's call this header user, like what is the user, and use user 123 just for the example. So right here in the request you have a new header. Great. Absolutely. You have just mastered the two most fundamental parts of ASP.NET architecture. You have built a professional control panel with the options pattern and a filter system with middleware. Your application is now ready to handle data securely and process requests like a pro. In the next lesson, we are going to take a deep dive into SQL databases. Before we start creating our databases, let's take a step back and answer one simple question. Why do applications need databases in the first place? Imagine you sign up for a new application. You create an account, customize your profile, save your preferences, maybe even upload some data. Now imagine the application shut down. If everything exists only in memory, every piece of information would disappear the moment the application stopped running. That's where databases came in. A databases give your application a permanent place to store information, allows data to survive long after your application has been closed or restarted. Every time you log into your favorite application, stream a movie, place an order online, or send a message, you are interacting with data that's being stored, retrieved, and updated inside the database. For backend developer, data become the application's memory. Your application decide what should happen, the database remember what happened. Throughout this course, we will be working with a relational SQL database where information is organized into tables and relationships. As we build our application, you will see how our C# object became database records, how data is stored efficiently, and how we can retrieve exactly what we need whenever a client sends a request. Don't worry if databases feel intimidating right now. We will build everything step by step, and by the end of this section, working with databases will feel a natural part of building backend application. So, now that we understand why databases exist, let's create our first one and start giving our application long-term memory. Before we can lay down the foundational and our actual application logic, system, and special features, we need a place to store our data permanently. We don't want our data to be as a variable and to reset every time the server stops. So for that, you already know, we are using databases. And in this lesson, we will set up PostgreSQL database using Doc. First of all, so now let's create our Docker compose file to launch our PostgreSQL database. So right here, let's add a new file. It will be a Docker compose file .yaml format. Great. Now let's define our services, and our service right here will be the PostgreSQL DB. Now let's take out our base image, and it will be Postgres at version 15 Alpine. We are using Alpine version because it's lightweight and efficient, perfect for our high performance application. Now we need to set the security route for our database. We will define the master username, password, and the default database username. Now let's add the environment variable to our services. So we will use the environment right here, and we will set up the Postgres user. So right here it will be user 123. Let's duplicate it and change it from the user to the password, and it will be password 123, nothing special. And also the Postgres DB. Let's set it a name. So it will be sp.net sp.net db. Great. Next, we will open a loading dock so our sp.net core application can talk to the database. We will map the port 5432 on our computer to the 5432 inside of the Docker container. And we will also set up the volumes, which are a permanent place on our machines to store the data. Let's say you accidentally stopped Docker and it's no longer running on your computer. If you didn't set up the volumes, all of the data that you have locally will disappear. And we don't actually want it. So let's set it. So for that we will use volume, so the data will not be deleted. Now let's map out the ports. Now let's map out the port inside of the container to the ports of our machine. So let's do this right here. We will use ports and we will map the port, the natural port for PostgreSQL, which is 5432, to the port of 5432 on our machine. Next, we will add the volumes. A volume is a permanent place on the machine to keep our data. Now, when we are developing locally, most of the time we will not need the data for long term. We just need it for testing, for checking things out and all of that. But when we are talking about a production environment, we will need to store the data somewhere safe, no matter if the Docker stopped for a second. So for that, we will use a volume, which is a permanent place to store the data. So for that, we will use Postgres. Let's give it a place and a name. Postgres data /var /libl PostgreSQL /data. This will be the place when we will store it. And finally, we need to define the volumes. So volumes right here, and it will be Postgres data. And this is how we are defining. Nice. Now your database is ready to run. Now we just need to tell Docker to build and start our database. Once the container will run, PostgreSQL will be waiting for our sp.net application to start sending data. Now let's launch the database through the terminal. So let's go over the terminal and let's write this command. So docker compose app-d. So let's click on it. So now let's open up the terminal and write docker compose app-d. Now you see this, I'll explain exactly why we got no configuration file was provided. Now, if a little bit of Linux, which I highly recommend you to know a little bit of commands, you will do the ls command to list everything in this directory that we open the terminal. Right here you see two things, and this one is the folder. This one right here, the learning ASP.NET, is the folder right here that we have. If you look closely, we have just this folder, and we open the terminal on this folder, not on this, and the Docker file is in this directory. So for that, let's just go inside it and let's run. Now let's run docker compose app-d, and it's working because we do have the compose YAML in this folder. Great. Now on my machine, I already download PostgreSQL and use it a few times, but on your machine you may see a loading bar and it would take time until it would load the current version of PostgreSQL. So if you see a loading bar and if you see something different from what you see right here, do not panic, everything okay. So we run our Docker database locally, which is amazing. Instead of downloading large files, a database, all of that stuff, we just use Docker to run our database super fast and super amazing. And in the next lesson, we will talk about the core migration. Now that we have PostgreSQL running inside of a Docker container, let's continue to the next part of the entity framework, the entities themselves. Think of an entity as a blueprint for our .NET application. Imagine you are an architecture building a large apartment Before you lay a single brick, you need a master blueprint that defines exactly what every room looks like and how they are connected. In the entity framework, an entity is a blueprint, a simple C# class that tells .NET exactly how the structure of your database tables would look like. Before we can design our blueprints, we need to install the entity framework core for PostgreSQL, which will give us the tools to model our data. So let's do that. But before we'll do that, there is a very good feature in IntelliJ. Right here on the right side, you have the database. Right, this one. And we can add a database data source right here. We can add PostgreSQL, and we can actually connect to our database, to our Docker database locally, and see all of the changes happened live. So let's use user123 as the username, password that we did, and the database call sp.net_db. Now we will use this test connection, and the connection is valid, so let's click on OK, and now we can monitor our database right from here. Amazing. Now let's install from the terminal. The entity framework. So let's go to the terminal and write out this command. .NET add package. This package start with npgql.entity framework core, and we will use the PostgreSQL. So PostgreSQL. Now let's install it, and there we have it. Now an entity is just a standard C# class, but we can make it smarter with data annotation. Those ones are like professional safety signs. Great. So there we have. We install our package, our dependency successfully. Now that we have our dependency, let's create the entities. Now, entities will mirror our database table, which means they will have the same fields of the column. Each field in our entity will mirror one column in our database table. For example, if we have the name column, we will have the name field in our entity. Now, let's create the first entity, which will be the user entity. So right here, let's add a new class. It will be called user. Now, each table has an ID, so let's use it. Now, in .env, unlike other frameworks like Spring Boot, we first of all will create the entity and then the code. Now, how does .NET knows that this field is the ID? The fact that it has an ID and its name doesn't matter. We can call it identifier or user ID. This isn't matter. Thing that will make .NET understand that this is an ID is something called data annotation. Data annotations gives more information about a field and tell exactly what it is. So if we want to make it a primary key for our table, we will use the key annotation. So let's use the key annotation and let's use it from here and just bring into Rider. Put this right here. Great. And now a user needs a few more fields. So he obviously would need a name. So let's add the name and let's initialize it into an empty string. Now in a database table, we will have a few validations. First of all, not null. So how exactly not null look in .NET entities? It would look like the required. Great. Next, we can add more validations, like when we are using varchar, we have maximum characters. So we can use max length, and we can put it at 50 characters or 100 if you like. Now, let's add the email field and a little post collections. Wait, a collections? Exactly. Why do we need a collections? Because a user can have many posts. This is a one-to-many relationship in an SQL database. It is like saying one user can own multiple parking spots in our applications. Now, let's add the email and the relationship property. So right here, let's add the email. So will be a public string for email. And now let's add our data annotations. First of all, the email will be required, and second of all, it will be an email address. This is a special annotation that will not, and you will not have any equivalent for it in SQL. You don't have any validation like ensure email or not email or something like that. Now let's add the post. So it will be a public list of posts, and we didn't create the post yet, so just a second, and we will call it post. And let's first of all set the get and set for it, and it will be a new, just like that. Now we need the post entity. Every post must belong to a specific user. This is a foreign key, if you can recall. Think of it as a resident ID card that every piece of furniture in our apartment must have to prove it is belonging there. Now let's define the post entities. So right here, let's add a new entity, and it will be the post entity. Now before it, let's insert it into the models folder. So if we want to insert it into a model, we need to use the slash, and this is a directory now. Let's put the user as well. Click on OK. Great. Now for the post, we can import it. Great. Now let's add the ID. So ID, let's add the key annotation to tell.net that this is the ID field. Next, we will add the context and the link back to our user. We use the user ID as the actual foreign key in our database table, and we will use a user field of the type user as a navigation property, so we can easily jump from post to its another in C#, from post to its author in C#. Now let's add the title and the user relationship. So title is super quick, we are already familiar with it. Title, and let's add the required, and let's add the of integer, and it will be the user ID, and will be get set and the user. Now for the user, it can be null, so let's put a question mark on it. Great. Now that we have our blueprint, our entities, we need to control them. This is the DB context, the application DB context. This class is the heart of our data layer. It tells the entity framework or which C# classes represent which tables in our system, and it exposes our user record throughout the DB set. Now let's create the application DB context and expose our users. So let's create it right here. Let's create the DB context. Let's call it application DB context, and we will put it in the data folder, and it's a little nice shortcuts. So let's create it. Now this application will use the DB context. Great. And right here we will add an empty constructor, so public DB context, and it will take a DB context options with DB, and it will be options, and we will use base options, and we will put it empty. Next we will define a field, so public, it will be a DB set of our user, and it will be called user. Sometimes basic annotation aren't enough. We need the Fluid API for advanced architecture. It is like sitting down with master engineering to fine-tune exactly how the pipes and wires are connected deep inside the wall. We will use the with1 method to tell the entity framework exactly how the users and posts are linked, so that if we delete a user, our database knows exactly what to do with their belonging. Now let's configure the relationship and close our context. So let's start to configure it. It will be a protected override void, and it will be on model create. It will take a model builder, and let's start the method. So we'll use model builder with the entity of user, and has many user posts, and with one user post, and on delete we will use cascade, but before it we will use has foreign key in the post. So right here we're training a few methods. So right here we are training a few methods together. First of all, we're telling that the users has many posts, and then we said that each post has a foreign key for the user ID, and under it we will use the cascade option. Excellent. You have just built a clean production-ready data model with validation and complex relationship. And this now we are going to learn how to manage our entities like professional. Think of the entity framework core migration as a professional translation team. They take the high-level C# entities we just designed and translate them into low-level SQL commands that our PostgreSQL database understands. Migrations allows us to evolve our database structure over time without losing any data. It's like adding a new floors to our application while people still living inside. Before the entity core can build our blueprints entities, we must hire the design crew, quote unquote. Before the entity framework can build our blueprints entities, we need to install our dependencies. So we need to install the design package using the .NET CLI tool. So let's go over to the terminal right here and let's add it. So .NET add package, and this one will come from soft Microsoft for the entity framework core, and it will be the design. Now let's install it, and there we have it. Next we will register our application context in the program.cs file, telling it to use our PostgreSQL database through a connection string. Next, we will register our application context in the Great, we install it. Next, we need to register our application DB context in the program.cs file, telling it to use our PostgreSQL database through a connection string. Without this registration, the tool would not know which database provider to use. Now, let's register our context and add the connection string. So, open up the program.cs file right here. We will remove the extra stuff that we had earlier. Now let's go on to the builder right here. Let's add a new builder, and it will use services, and let's add a DB context. So add DB context. This one will be the application DB context, and let's go with the options, and options dot use and PostgreSQL. Right here we will configure and builder configuration, and we will get the connection string right from the settings. So let's go on to the application settings. Right now let's add our connection string. So let's remove this one right here. Let's have the connection strings. Let's add the default connections. Great. Now let's use server, so we'll tell it local host, and it will be on port 5432. Next, for the database, we will use the one that we have defined in our YAML. So now for our connection string, let's define it right here. So connection string, and let's define the default connections. So the default connection, and it will be, first of all, let's define the host. The host will be local host. The port will be 5432 PostgreSQL port. Next, the database will be the one that we define in the Docker YAML file. So let's just copy it from here. Next, we will have the username, which will be user123, and finally the password, which will be password123. And for the final configuration, we will use the trust server certificate, and we will set it up to true. Great, so this is for the connection string. Next, let's run the migration commands. Now for the actual magic. We will generate our first entities to SQL tables. We will use the .NET CLI to compare our C# code with our current state of our database. Since the database is empty, the entity framework will generate a foundational blueprint to build out our first table. Now, let's run the migrations command in the terminal. So, right here, let's run .NET Entity Framework, EF for short, migrations, add the initial create for initializing it, and we have a success build. Finally, we will apply our blueprints entity to our PostgreSQL container. The next command will send the generate SQL instruction to our database, building the physical tables and primary key exactly as we defined them in our entity. So now let's update it. So .NET Entity Framework EF for short, database update. Let's run it. Great, our migration was successfully, as you can see the build success. If you are seeing something like that, you can ignore it. It has nothing to do with the actual migration. So we finish it with our migration. Your .NET application now has its first official data foundation. By using the entity framework migration, you ensure that your database schema is versioned. By using the entity framework, you ensure that your database will have a consistent migration and will be safe to evolve as our application grows. Now we have set up the database using Docker, we have the entities, and we understand how to use migration. Next, the most important part, how does we actually communicate with our database from our .NET application. For that, we will use the extremely powerful Entity Framework Core API for our database, and I will show you how to use it. Now, unlike other frameworks like Spring Boot, we don't need another layer like repository or our system. We can use it directly inside of our code. So I will now show you exactly how to use this powerful API that the Entity Framework provides us with. So let's go on and create a new class. It will be the user service, and we'll have a lot of method writer like get user, create user, and more. And it will be inside of the services directory. So let's click enter, and now let's create it. First of all, we need the application context to make. First of all, we will need one field, which will be the context for our DB. So it will be private, read-only, application DB context, and it will be the context. Great. Now we will define it in the constructor, and let's create a method for creating new user. So it will be public asynchronous, and it will be a task synchronous, and it could return user, and it will be called create user. And we need a few fields that we have right here in the user, and we need the name and the email. Right now we can ignore the post, so we will need the name. Let's remove for now the email. So we only need the name and the email. So first of all, we will have the string for the name and the string for the email. Now let's have the user. So user, and it will be a new user, and let's put name to name and email for email. Great. And finish up with that. Now we will use the context to add this new user. So context.user.add this user, and we will save the user. So wait, we will use the context to save the user. So save changes, and we will return the user. Next, let's create a method for getting the user. So it will be asynchronous, and it will be task on user. We will get the user by its ID, so we may not have it, and it will be called get user by ID, and we will use an integer for the ID. Great. Now we will return the context user, and it will find asynchronous the user with this ID. Now finally, let's create another method for deleting a user. So asynchronous, this one will return a boolean and it will be called delete user by ID, and we will get integer for the ID. Now we need to get the user, so var user, and we will wait and we will use the context dot users dot find asynchronous, the one with the ID. Now if user is null, in that case we will return false, as we don't have any user to delete, to begin with. But if we do have a user, we will remove it. So we will use the context users and the remove method, and we will remove this user. Now we need to save those changes and we will return true. Notice that every time that we made a change, we need to save it. Now before we finish, I want to give you another thing to think about when you're creating those methods. Now those methods are transactional methods, which mean they happen in order, and if the method stop in some point, it would roll back. Now I will show you exactly from which point you roll back and from which you will not. Right here, we didn't make any changes to the database, nothing at all. But right here, we remove the user from the database. It's very similar to what we did right here in the create user method when we added the user to the database. Now, in this state, if something happened and the context added the user, but it didn't manage to get to this next line to save the actual changes, everything will roll back and the user will not saved, or in the delete user method it will not be, and in the delete user case it will not be removed. But if we came to this line and we stop right here, everything great, and it will be deleted. Great. This is how we will use the Entity Framework API to communicate with our database. It's extremely easy to understand and the code is super readable. So this is for SQL database, and I'll see you around. Before we build our first API, there is one concept you need to understand. Actually two: HTTP and REST. These two technologies are the foundation of almost every modern web application. Whatever you are building with Net, Spring Boot, Express, Django, FastAPI, Lever, or Go, the same principle applies. Once you understand HTTP and REST, you will start seeing them everywhere. So let's start with HTTP. HTTP stands for Hypertext Transfer Protocol. Despite its name, it isn't just used for text. Today, it's the standard protocol that allows applications to communicate over the web. Every time you open YouTube, log into your bank, order food online, or refresh your Instagram feed, your device is sending HTTP requests to the server. The server processes those requests and sends back a HTTP response. That's how the web works. Every communication follows the same pattern. A client sends a request, a server receives it, the server performs some work, and finally it sends back the response. The client can be anything: a web browser, a mobile application, a desktop application, another backend service, or even a IoT service. Likewise, a server can expose its functionality to thousands or millions of clients at the same time. But what exactly is inside HTTP request? Every request contains several important pieces of information. First, it includes an HTTP method, which tells the server what kind of operation the clients want to perform. Then, it includes a URL, identify the resources that the client wants to access. It may also include a headers, which provide additional information such as authentication token, content type, caching rules, and much more. Finally, some requests include a body, containing data that should be sent to the server. For example, when creating a new user or submitting a form. After processing the request, the server returns an HTTP response. That response also has a structure. It contains a status code that tells the client whatever the operation succeed or fail. It contains header with additional metadata, and in most modern applications, it contains a JSON payload representing the requested data. Now, let's talk about the difference of HTTP method. The most common one is GET. GET is used wherever we want to retrieve information from the server. If we want to create something, we actually will use POST. If we want to replace 10 existing resources, we typically use PUT. If we need to update part of the resources, patch is often the better choice. And if we want to remove something, we will use delete. These methods don't just describe action, they establish a shared language between client and server. When developers see GET request, they immediately know it's meant to retrieve data. When they see delete request, they expect our resources to be removed. This consistency is one of the reasons modern API are so easily to understand. But HTTP only defines how two systems communicate. It doesn't tell us how an API should be designed. That's where REST comes in. REST stands for Representational State Transfer. The name sounds complicated, but the core idea is surprisingly simple. REST encourages us to think in terms of resources instead of actions. Imagine we are building a movie watchlist application. What are the resources? Movie, user, reviews, watchlist. Each of these resources gets its own unique URL. The URL identifies what we are working with. The HTTP method identifies what we want to do with it. For example, a GET request to slash movies retrieve movies. Post request to slash movies will create a new movie. A GET request to slash movie slash 42 will retrieve a specific movie. A put or patch request updated and a delete request removed. Notice something important. We are not just creating endpoint like create movie, update movie, or delete movie. The resources stay the same. The HTTP method change. This makes API predictable, intuitive, and easy for developer to understand without reading extensive documentation. REST also encourages other important principles, stateless communication. Every request should contain everything the server needs to process it. The server shouldn't rely on information from previous requests. That makes the application easier to scale, easier to deploy across multiple servers, and much more reliable in production environment. Another conversation you will see in REST API is the use of meaningful HTTP status code. A successful request might return to 100, creating a new resources often return to one created, and if the client sends invalid data, the server might respond with 400 bad requests. If authentication is missing, you will commonly see 41 unauthorized. If the request resource doesn't exist, the server will return 404 not found. And if something unexpected happens on the server, you will usually receive a 500 internal server error. This status code allows the clients to understand the outcome of a request without even looking at the response body. By combining HTTP method meaningful URL, status code, and JSON response, REST creates a consistent way for applications to communicate regardless of the programming language or framework behind them. Whatever you are building backend with .NET, Spring Boot, Java, Python, those principles remain exactly the same. Throughout this course, every API we build will follow those conventions. Once you have learned HTTP and REST, you are not learning any specific framework. You are learning the language that modern software systems use to communicate. And now that we understand the language, let's build our first REST API. Let's talk about the most interesting part of the application, the API. We expose our application to the outside world using the REST API, and we learn how to protect our data, how to expose only the parts that we want the end user to see, and of course, how to make our code cleaner and beautiful. So, before we start, we need to do one thing that we forgot to do earlier, and it is to register our service to the program CS file. So right here, in the builder, So right here we will use builder.services and we will add scope for the product service. Yes, and this is it. So .NET will inject the product service wherever we will need it. So it will inject the product service wherever we will need it. So let's close it and let's create our new product controller to learn everything about how we will use REST in here in our ASP.NET application. To learn everything about how we will use REST in our .NET application. So let's create this class. Now .NET does not know right off the box that this is a controller. The fact that we use a controller in the naming does not tell .NET anything. To tell .NET that this is a controller, we will use an annotation. We will use the API controller annotation. So API controller annotation, and now .NET knows that this is a controller. Now we should route this controller to a specific endpoint. Let's say someone goes into our application, so application.com. This is the main page. When we will enter the product, it will get to this endpoint that we have right here and could reach and can have all sorts of stuff like get a new product, post, create a new product, delete, and also update a new product. All four of the CRUD operation. So to actually tell Spring that we want this to be in this specific endpoint, we should have another annotation. It will be the route, and it will route it to, first of all, this is the convention to /API, and we will use right here the controller. Now we also need one thing, controller base. So these annotations, Spring Boot tells .NET exactly where we will route our request, and it will be at /API/product. Great. Now we need our product service that we have created earlier. So it will be private, read-only, and it will be the product service, and it will be the product service. Now in the controller, right now this is the controller, and we will get the product service and we will define it. Right here, ASP.NET will inject the product service to here. Now let's create a simple get endpoint to get a product by its ID. We have already created this method right here in the product service. We have created this method that called get product by ID. So we want to use it right here to get a product by its ID. So it will be public, it will be asynchronous, and when we use the asynchronous we need to use a task, and the result will be a product, and it will be called get product by ID. And right here we just need to use this method from the product service. Super simple. Now this should be a get endpoint because we only reading data and not modifying it in any way. So how does exactly we tell .NET that this is a get endpoint? We will use a simple annotation that's called HTTP get. Like get we have HTTP delete and HTTP post, put, etc. So we will use HTTP get, and now it's known that this endpoint is to get new data. Now for the ID, where exactly does the ID came from? Because it should came from somewhere. As we discussed earlier about the HTTP and how the body and how we have a lot of parts like the header, the body, etc. We should understand exactly where this ID would came from. Now it could came from the body, and if you want the ID to came from the body, we will use a nice annotation called from body. This annotation will tell .NET to expect to get the ID field from the body of the request. Now in most cases we will not get fields like main, we will not get fields like ID in the body, and we will get it in the request. So the request would look something like that, application.com/API/product/1 for the ID, or 2 or 3 or 78 or some number for the ID. So we need to get it from the actual request from the query parameter. So we will expect to get it in that. So let's add right here this symbol and we will write ID. Now when we add it, we tell .NET that we expect after the slash product to have extra something for the actual ID. So this is the part. Now we don't expect, now .NET see that it is get an ID from the header, but it's expect to get from the body. So we need to change it right here to get from the body, and all we need to do is just remove it. And .NET knows to direct that to the right place. So great, so we map our request. So great, we create a new endpoint for get with the ID. Now it's great and everything, but we don't want to return just the product. We need to return a REST API response, which would include a response status, and the result will be inside of the body of the response. So for that, we will not return a task of product. Instead, we will return task of I action result. This interface expects certain result like HTTP statuses like 404 not found in case we didn't found the product, and 200 OK in case we did found the product. So we will use it. Now there is a red line because we are returning the product and not the actual result. So for it, let's first of all keep the product in a variable pro, and now we need to decide what kind of response we will return. So if we don't have the product, so product will be null. In that case, we will return a not found response, which a not found response 404, which tells the end user that, hey man, there isn't any product in our database with that ID. Great. But if the product exists, it's not null, we will return OK with the product itself. Great, so now we are returning a nice response. But there is still a problem. If we would go ahead to the product, if we will go to the product documents, we will see that we have this metadata. Now, let's say we don't want to return the metadata to the user, we just want to return the name and the price and ID, nothing more. So we shouldn't return the entire product. For that, we have a solution called DTO, Data Transfer Object. DTO are used when we want to exclude certain information from the response. Let's say a user wants to get his information. If we will return the entire user information like name, email, and password, this is a problem because there it will be easy to breach out and take the password, which is a sensitive field that we don't want anyone to have access to. So we need to remove the password from the response. So we will use now DTOs to exclude the metadata from the response. So for that, we will create a few DTOs. So right here, let's add a new class for the DTO. Now this one will be the product DTO, and it will be inside of the DTO directory. So let's create it. Great. Now the DTO, the response should be, now the response should have only the name, the price, and the ID, nothing more. So let's create it. So it will be string for the ID, it will be for the name, and it should be a decimal for the price. Now we need to initialize it to an empty string Great. Now we need to map our product to the DTO. So for that, we'll go to the product service and add a new method right here, which will be called, it will be a private method, which will return a product DTO and will be called to response. We will take a product, and now let's create the mapping. So we will return ID, name, and price. So now we map it into a proper response, and now we will return, each time we return a product, we will return a product DTO. So which means that we need to map this. So let's use the toResponse method right here. Great. Right here we also return a product, so it should be a product DTO. Map it into a product DTO. So we have a few ways to do this. We will use the one with the select. First of all, we need to create it with, we need to save it as a variable. So product will be, now we will return product.select. We will use the toResponse method and we will change it into a list. Great. We can chain all of this. If we will just do something like that, we can connect all of this together. But so this is how we use it. Great. Now finally, right here, it does not return a product. So yes, so we change everything to product DTOs. Now for the controller, right here, nothing has changed because we're using var and returning no found. Great. So now we are returning a proper response with no found, and we excluding certain fields that we don't want. Absolutely amazing. Now let's add the post method to create new product. Now for post we will use the post annotation, so HTTP post annotation, and it will be also asynchronous, a task of result, and from the body it will get the DTO. So the exact DTO that going out is similar to the one going in, but we will not want the exact DTO to be. We want a different DTO because we don't exactly want the ID right there. So right here the ID is optional, but let's create a new product request which will only have the most necessary field, which are the name and the price, and everything else will just be noise. So let's use the product request. Let's call it request, and now let's implement it. So let's use the product service. So wait, now product service dot create product, and we need the name. So request dot name and request price, and in the end we will return OK. Or we can return a regular OK, but it's more common to return a 201 created when we are creating new things like product, users, etc. And in the 201 created, we will also return a URI, which is the location of the new resources that we created, and we will return the URI in the header. Now to do this, we need to change the signature of create product method. So let's go right here, and it should return a product TO as well. Now it should return, and we should map it into our response with the DT. So right here we need to change the signature to return a product DTO. So a product DTO. Now after this happens, MongoDB will populate this new product that it has created with the ID, which means we just need to return the product and make it into our proper response. This method that we did right here. Next, let's move on to the controller, and right here we need to save the new product, and for the created we will use created action and enter, and it will use a name of get product by ID, not important, but this will be the value of the location, and it will create the location automatically with the ID that we give it right here, and with the actual product in the body. So this is a more proper response for the post operation. Next, let's create the put operation. So http put. Great. Now let's create the method. Will be a task. It will be update product, and we will get the request to update from the body. So from the body, now we need to get the actual ID from somewhere, so we will know where to look for the product. So we will get it from the request ID, and we will add it right here. Nice. Now let's update the product. So we will await the service dot update product. We first need ID, and then the request name. First need ID, and we also need the request. Now let's go to the product service. Now we are expecting to get a product object. Instead, we need to get the ID for the string and a product request and a product request as well. Product. Now we will find it with the ID that we have right here. Right here, let's change it to the ID. And there is this red arrow, so we need to get to the actual method and change it a little bit to match. First of all, we need to change those fields. First of all, we have the string for the ID and the product request with the request itself. We can call it request or product. Now we need to change this method a little bit. So let's start. So right here, we need to create first of all the filter to find the product by its ID. We will use the builders of the product and we will filter find the product with the right ID. Next, we will update it. So update it using the builders for the product and we will use the update and we will set the name first of all, and the next we will set the price as well, and that's it. Now we need to update it, so we will use the result and we will update it with a filter and we will return if the result is modified, if we did have a modify count, and is acknowledged. Now let's go into here and beautiful, everything is working. Now we need to know exactly what to return, so first of all var, let's call it updated dated. Now it's return a boolean, so if updated. Now this operation returns a boolean, so we can change it to a boolean as well, but let's just use a var to make things looks better, look simpler. So we can use an if operation if it wasn't updated. So if the product was not updated, we will return a bad request, but if it was updated, we will return no content, which is 204, which means no content, which is the operation was successful and there is nothing in the body. This is the same standard that we are using in operation like updating things and deleting things. Finally, let's create the delete operation. Now the delete operation will use the ID and we'll get it from the query and we'll get it from the URL. Next, asynchronous, it will return a task function and will be called delete product. Now it's super simple and it's very similar to what we did here. Let's just do it right here. So we need the deleted, we will use delete with the ID. If it wasn't deleted, we will return a bad request. If not, we will return no content. Nice. So we have created a full CRUD operation. So right here we have created our first controller. We first of all start by understanding how to expose a new endpoint to the world, how to get parameters and information from the request, and how to retrieve a proper response with mapping a certain object to where they are belong to. We also understand that the OK response 200 is not fit for every single request, and sometimes we should return other response like 201 created or no content 204. So this was the API, and before we start securing our application, let's answer a much more important question. Why do applications get hacked in the first place? The answer isn't usually because hackers are smarter than developers, it's because software is built by humans and humans make mistakes. Every application exposes an attack surface, a collection of places where users, system, or other applications interact with your software. Every login form, every API endpoint, every file upload, every search bot, every request coming from the internet. Each one is potential entry point. Most users interact with your application exactly the way you expect them to do. Attacker doesn't. Instead of asking, how do I use this feature, they ask, what's happened if I send something the developer never expected? Maybe they send invalid data, maybe they modify a request before it reaches your server, maybe they try thousands of passwords, maybe they attempt to access data that belongs to other users, maybe they look for information your application accidentally exposed. Security isn't about assuming people will follow the rules, it's about assuming someone eventually won't. That's why secure software is built on one simple principle: never trust the client. It doesn't matter whether the request came from your own website, your mobile application, or a tool like Postman. Every request can be modified, every value can be changed, every HTTP header can be forged, every piece of client-side code can be bypassed. The server must verify everything, always. Throughout software history, some of the largest security breaches weren't caused by incredibly sophisticated attackers. They were caused by small mistakes. An API that forget to check permission, password stored as plain text, a SQL query vulnerable to injection, a missing authorized check, an exposed API key, a forgotten debug endpoint. Tiny, oversized, massive consequences. That's why security isn't a feature you add at the end of the project. It's something you think about every time you write code. Fortunately, modern frameworks like .NET, Spring Boot, Nest.js, Django, and more provide many of building blocks needed to create secure applications. Authentication helps verify who a user is. Authorization determines what the user is allowed to do. Input validation prevents unexpected or malicious data from reaching your application. Parameterized database query help eliminate SQL injection attack. HTTPS encrypts communication between client and server. Password hashing ensures that even if your database is compromised, user passwords remain protected. Logging and monitoring help detect suspicious activity before it became a major incident. But here is something important to remember. Security is never absolute. There is no such thing as a perfectly secure application. Instead, security is about reducing risk, making attackers more difficult, limiting the damage if something goes wrong, and consistently improving your defense over time. Throughout this course, we won't just learn how to use different security features. We will learn why they exist, what problem they solve, and how to apply them correctly in real-world application. Because writing software that works is one half the job. Writing software that's secure is what separates working applications from production-ready ones. So, with that mindset in place, let's begin securing our application. Now that we have finished with everything connected about the web, let's dive into security. Now we will turn on ASP.NET Core built-in security features. We will register the authentication and authorization services, add JWT support so our application can read tokens and protect an endpoint with authorized annotation. Let's start by registering the services. So go over to the program CS file, and right here in the builder, upward in the builder, we will add two services. So builder services, and it will be add authorization. So we will add authorization and authentication. No, we will add authentication, then authorization. This is authorization, this is authentication. Next, we will install the JWT bear package. It will add the handler that will read and validate tokens on incoming requests. We will configure it fully in a bit. So go ahead to the terminal, we will install it right away. So right here, .NET add package, and it will came from Microsoft.ASP.NET Core authentication authentication.jwt bear. So now let's install it, and there we have it. Finally, we will protect the route with the authorized annotation attribute. Any request to this endpoint without a valid token will be rejected before the method will run. So now, just for the demonstration, let's go to the controller and welcome controller, this super simple controller that we have, and let's add the authorization. So authorize, and let's import it. Now let's put this in a new endpoint that will be called welcome. Now let's run the application and show you that if we would try to reach this endpoint, we will get an error because we are not authorized for this endpoint. So let's just run our up our application. Great, now let's go ahead, copy this and go ahead to Bruno. Now let's open a new collection. Let's call it test security. And right here, let's add a new request for simple HTTP. It will be get/welcome. Let's send a request. So now let's send up the request. So these annotations protect the endpoints from a request that isn't authorized. Now let's jump into JWT authentication. So now we will set up JWT authentication in ASP.NET. A JWT is a signed token that the client sends on every request to prove who they are and what they are allowed to do. We will store the token settings in configuration, register the JWT bearer service, add an authorization policy for admins, and protect an endpoint. So let's start with the settings. First, we will add the JWT settings to the application settings.json. The key is the secret used to sign and verify every token, so it must stay private. The issuer and the audience's identity who creates are the issuer and the audience identity who creates the token and who it's meant for. So let's open up the configuration, so application settings, and right here we'll add the new configurations for JWT. So it will be JWT, and we will have the key, which will be a JWT red key variable, be sure, and it will be something like my skyscraper just for it. And for the audiences of the ends, we will use my residence. So for the actual JWT secret key, you will go to the terminal and you will write this command: open SSL random dash base 64, and you will choose the length. Let's choose 64, and we will get the secret for the JWT. Now let's export the JWT secret key, so JWT secret key, and let's assign it into this key, and now we have this secret key. Now we will register the authentication service in the program CS with add authentication, and we also add the JWT bearer, which will tell ASP.NET Core to look for a JWT on incoming requests. So go ahead to the program CS file and let's add this. So right around here, let's go on for the builder.services.add authentication, and right here we will add JWT bear default dot authentication skill. This is the, and add W to this method. So options dot token valid parameters is defines what make a token valid. We will valid the issuer, the audience, the expiry, and the sign key. If any of those does not match, the request will reject. So let's do this. Assign it into a new parameter, and let's use, first of all, valid issuer we will set to true, valid audience to true, valid lifetime to true, valid issuer sign key to true as well, and the valid issuer we will set to JWT issuer. So JWT issuer, we will set it up to that configuration, and we will do the same for the audiences as well. Now for the sign-in key, so issuer sign-in key, we'll assign it into new systematic security key, and we need to encode, so encoding.utf, and we will get the key from here. And that's for it, and we have finished with this method. So what we did right here is said all of those should be true, and we just set the issuer and the audiences and tells .NET exactly from where exactly good to get them, and we set it to get them from the configuration that we have in the JWT at the issuer, which will be the configuration. And we do the same right here. And the same goes right here, but we need to do a few steps before it because the JWT is a complex key and we need to make a few steps before it. Great. Now we need to go into the authorization policy. A policy that lets us require specific conditions before our request is allowed. Here we will define in a bit the admin only policy that requires the user to be only in the admin role. So let's add this configuration. So it will be the builder, services, and we will add the authorization. Now right here we'll use options and we will create a simple policies with options dot add policy, and it will be admin only, and it will require the roles of an admin to be function. So just for an example to show you what this means, let's add a new controller. It will be the admin controller. Let's add the API controller and the route. So we define the controller. Next, let's create a simple HTTP GET for just public string of get some secret data, and let's make it super quick, and it will just return data. That's all. Now let's add the validation to ensure that only admin can access these resources. So right here, yeah, let's add controller base as well, and right here we'll add this. We will add right here the authorize with, let's import it. Now let's add right here the roles, and the policy would be admin only that you have defined. So let's check it out. So right here, let's run up the application. And now let's go into Bruno. So now let's put up the URL. So it will be http://localhost with the port of 5216. And let's go to admin. Let's send the request to /admin, and we get 401 unauthorized. Unauthorized is just simply mean that we don't have the authority to go into here. Great. So our validation is working. So let's up our validation. Great. Now we protect our endpoints. We can protect the entire product endpoints if we want as well. We can go ahead and put an authorized right here, and be aware that you take it from the Microsoft one and not from the hot chocolate one, because this is the one that we are actually needing. So click enter, and now we cannot reach the product endpoints if we want it. So let's run, and in Bruno, if we try to reach the product, the /API /product endpoint, /1. So right here in Bruno, if you try to reach /API /product not that let's try to create a new product. So post with the body in JSON, what we need in the post actually, just a second. So right here we need the name, which will be iPhone, and the price that will be $99.99. Let's try to send it, and we are unauthorized. Now let's go back and remove this authorize. Let's comment it out. Now let's refresh right here. Beautiful symbol. So right here, let's send the request again, and we get a 2-1 created. We create the product successfully. Great. So this means that this is how we protect our endpoints. Now let's go ahead to the next level and actually implement logging authentication and actually get users to have the JWT token that they need to use our application. So let's tap the application and let's start to implement. Now we will build a service that will issue JWTs. When a user will log in, it will take their details, pack it into a claims, we call it, sign the tokens, and then return it as a string to the client, and then the client will be responsible to store and send it back for every request. So now let's create the class. So right here, let's add a new class. It will be the token service, and it will be inside the security or JWT. Let's put security for now, let's call it. Great. Now we will put the token creation in one place inside of this token service class. So now that we have the token service, we need one field will be private for the configuration. The configuration, we will need it to access the configuration in the application JSON. So let's just add it and use the constructor, and net will inject it for us. Now let's create the method to create a new token. So we will call it create token, and it will get the user to actually create the token. First of all, we need the keys. So string will be secret key, and we will use the configuration, and we will get it from here, and it will be inside the JWT key. Now let's make a quick check. If strings null or empty, if our secret key is null or empty, we will throw this new exception with the message of JWT secret key is missing. Let's put exclamation mark. But if we does have it, we will need to create the actual key. So var key, it will be new sim security key, and we will encode using encoding for the bytes. So encoding utf8 dot get bytes from the beautiful secret key. So this is it. So right now we need a new variables. It will be the cred, and it will be the new signing credentials, and inside that we will put the key that we have and the algorithm, which will be security algorithm dot h signature hmax. I can't read it, so the 256 signature. So let's use that. Now we will set up the claims. Now claims are the pieces of data that carries inside of the token. It will include the user ID and name, and we will wrap it inside a security token descriptor. So let's create it. So right here, var token descriptor, let's call it the descriptor, and it will be assigned to a new security token descriptor. This is the one, and we will start by setting up a few things. First of all, the subject, we'll assign it into a new claim identity, which will be new array, and right here we'll have it. Right here we'll have new claim with claim type claim types dot name identity, so name identifier, and it will be the user ID. Now we'll need another claim, so new claim, and it will be the type of name. So claim types, it will be a simple name. It will be user.name, and that's for the subject one. Now the expires, we'll set it up to data time dot, we will set it up to date time dot UTC now, and we will add 7 days. To the expiration time, it will be 1 week. And for the signing credentials, we will use the credentials right here that we have. We can also call it credentials right here. I just remove the capital C. So credentials. Now we finish up with that. And finally, we need to return this token. So right here, we need the var token handler to handle the token. So new JWT security token handler. Now we need the actual token. So we will use the token handler to create the token, and then we will return it to the client. So right here we are creating the token handler, then we're using it to create the actual token, and then we return it to the client. And you can also just copy this. This is another shorter approach, but right here with all of the code that we wrote, I think it's better to be more explicit. And you have it. So that's a working token service. Now we actually can create tokens fairly easily. So we have the token service right here. Next, we will add the refresh tokens so user can stay signed in without holding a long-lived access. So now we have the token service, and it's working with the create token method to create new JWTs token for authentication. Now let's actually use this method and give our clients tokens when they are registered and logging. So let's go ahead and create the authentication service, which will use the users entity that you have right here, and usually we will not handle users in a user controller, but in the authentication controller, because everything that handles with user in your application, and every application needs users, is actually super simple, and it's only the basic security stuff. So yes, you don't actually need any user controller. Now let's just add the password. So password, of course, super important. We can also add a few validation required, max length of, let's say, 36 characters, because we also hash it, min length of 8 characters for security, and that's about it. Now for the user service, let's update it. So right here in the services, user service, now we need to create user. Great. We need the name, email, and also password. Now usually we will extract it to a DTO, so it will be simpler, but for now let's just deal with it like that. Nice. And you may think that we will just do that password and put it like that. No. What we will do to the password, we need to hash it for security reasons. Now, password hashing is the process of converting a plain text password like this one into a unique fixed length strings of random characters that cannot be reversed or decrypted. We need it because storing password as a plain text in our database is a massive security risk, and if a hacker breached the system, they would instantly gain access to every user's account. The main benefit of hashing is maximum data security. Even if the data is stolen, the attackers only see useless lines of scrambled code, keeping the user's actual passwords completely safe. So let's hash the password. So for hashing the password, we will use bcrypt for hashing it, so using b. So now let's actually hash the password. So first of all, we need to add a new dependency. So right here in the terminal, let's use .net add package, and it will be bcrypt.net-next. We will install it. Wait a minute, I had a typo right here. Bcrypt. Second, yes, this is the right one. So there we have this package installed in our system. While we are at the terminal, let's update our migrations. So we need to update our database for the user service for the user's entity with this new password field column that we added. So let's use .net. So .net entity framework and migrations. Let's add this new migration. Let's call it add password use field. Now let's add this migration, and we did it successfully. Now let's actually hash the password. So use bcrypt.net bcrypt hash password method, and now we have the password safe in our system. Great. Now we will add the user right here. We save the changes, and instead of returning the user, we want to actually return the token. So great, we hashed our password successfully. Now we need to return not the user, but the username, email, and the token to the client. Also the user ID. So instead of returning the user, we need to return a new DTO. So let's add a new DTO right here. And it will be for create user request or register request. Both are valid names. And let's use the register user. And we need to add a few fields. First one will be a string of name, email, and instead of password, it will be the token. Great. So right here, we will return a register user request. So now let's create it. So register. Let's create a new request with the name, the email, and for the token, we need the token service right here. So let's use it. Private read only token service will be the token service, and we will inject it from here. token service. Now we need in the program CS to ensure that our service is here. So let's add the token service to here. Great. Now our service is valid. Let's also have the user service. We forgot it earlier. Great. Now we have the token service, and right here in the token we can assign it into the token service dot create token with the user. Great. Now we can return the register request. Great. Or we can instantly return from here and remove this line completely. Great. I think it looks better on one line personally. So there we have it. Now let's remove those extra stuff. We don't actually need it right here. So this will be the create user method or register user method, whatever you prefer. And now we need another method for logging. So it will be also asynchronous task. It would also return a register user request, but this one will be the login user method, and it will get a string for email and password. And now we first of all need to find the user. So we will find the user by its username. So let's use context.users.find async, and we'll find by the email. Now if we don't have a user, so if user is null, in that case could return null or throw new errors. So we can throw new exceptions with user not found. So now if we do find the user, and the user is not null, we need to ensure that the passwords are correct. Now how does we do this? We encode the password. So how exactly can we do this? There is a nice method called verify that will encode, dehash the password and give us the option to compare the password. What it will do, it would go ahead, find the way that the other password was hashed, the original password. It will find the original password that was hashed. Maybe it was hashed like that, random character. It will find a way. It may say it hashed like this ABC method. There is a lot of methods, bcrypt, more, and it will do the same for this new password that we try to check. Let's say password 123. It will do the same, and it will come up with a random set of strings, and then it will compare if they are both are the same. Doing this process, you can't exactly cheat the system, and if you really want to hack it and know only the username, it's a long ride for you. Now, to ensure that the hacker doesn't know if he got a right username, then he could check out the password across multiple passwords that he got. We can change it from user not found to username, or password is incorrect. We can change it from username to email or password is incorrect. So the malicious user will not know exactly what he got and what he doesn't got. He will not know if he got the right username. Next, let's check out if the password. So let's use bcrypt.net.bcrypt.verify the password. So first of all, we will put the password that we want to verify. So password and the user password dot password. Wait, we need the await right here. It's asynchronous, and right here we will use user dot password to find out the password. This throw new exception, email password incorrect. Now if this will evaluate to true if the passwords are correct. Now what if they aren't correct? We will go ahead and throw this new exception, which will be throw new exception, new exceptions of or incorrect is incorrect, and ensure to make sure that you throw same exception if you don't have the email or the user and if you don't have the password. So we will not reveal extra information to the user and tell him, wait, this email is correct but your password is wrong. No, it's best for security that the user will stay a little bit confused, and you enter to this website and said, what's your problem, just to tell me what is wrong. And this is the exact reason. I want to leak any information that may be on the line. So we give the same if we have the wrong password or the wrong username. But if we go all of this, which means we have a correct password and correct username, we can safely return a new register request. We can actually just copy this line from there. It will be a new register request with name, user, and token. So this is for the login. Let's go and actually create this controller. So let's go ahead in the controllers. Let's add a new, and we will call it auth controller. And now let's add the annotations for the API controllers and slash controller, and also it will inherit from the basic controller to have the relationship. And now the only thing we need is the service for the users. So right here, let's add a private read-only user service. Now I'll initialize it using the constructors. So we will initialize it. And now let's actually create the method. And now let's actually go ahead and create the register and logging method. Now you may ask, what type of REST request, because we will use REST, it's simple. What type of REST we will use for login? For register, it's easy, but for logging is quite complicated because we don't getting any information, but we don't updating anything, and we certainly don't deleting anything or creating new things. You get the point. So for those cases when you don't sure exactly on the method like login, we will just use the post because we're creating a new logging resources. So we will use that. So let's start with the register method. So it will return a user request as well. And from the body, we'll get a register user request. No. So let's go to the DTO right here. It will be the response. So let's just change it from the request to response. And let's add a few new DTOs. So first one will be register user request, which will have the public string for name, email, and password. Now let's use string.empty, and great. Now let's create also the login DTO. So login user request, and we'll go to here and just grab the password and email. So there we have it. So let's change it from register user response to register user request, and we'll call it request. So now let's implement it. So let's return created action for register with great. So now let's first of all create the user. So let's use the user service dot register user with the request dot name, request dot email, and request dot password. And let's put that. Great. So we have the user response with everything, but this is a asynchronous method right here, so we need to use await to use it. So await, which means that this should be asynchronous task. Okay, now let's check out. Now right here, we will have the user and the response with name, email, token, etc. So what we will do, so now we will put the token in the header. We have a few options for the token, and we will choose to put it in the header, which is super nice and is quite the convention, and also the front end will be super happy for it. So how does exactly we put this token in the header, you may ask? So it's super simple. We will go to the response object, we will go to the header, and we will append a new header, append, and this will be the authorization header, authorization, and inside it we will put the token. So right here we will put the user response dot token, but we also need to add one thing before it, which will be, and right here we need to add one thing, which will be the bear. Now it's important to add the bear as this is the convention, so don't ask any question. Now finally we should return to 1 because we created a new resources. So let's return created action. Let's use name of register. So let's use name of, and let's use register, and let's put the user response right here. And there we have for the register. Let's also direct it into /register endpoint. Now for the login, so it will be a public asynchronous. Next for the login, so login, it will be public asynchronous task, and we'll get the login request just like that. Now let's actually do that. It will be very similar. User result or response, user response. We will use the user service. We will use the login, and for the login we need the email and the password, and we have it in the request dot email and request dot password. Amazing. Now we'll append the token, and we need to return OK with the user response. We can return OK with the user name and email. So there we have all of our endpoints. Now let's go ahead to Bruno and check them out. So right here, let's run. Now let's go to Bruno. So right here, the product API can create anything, can create iPhone 18. Great. Now let's authorize it and ensure that we don't have access before we log in, and then let's ensure that we do have the access after we log in. So now let's run up the application and test this endpoint is working. So right here, run it. Go ahead right here to /API/auth/register, and we should have the name of the user, so it will be a username 123. We should also have the email, and we will set it up to user at email.com. And also for the password, we will do password123. Now let's send the request. So now we need to make few changes in the program CS file before we can actually check out this endpoint. So right here, we should change this from authorization to use authentication. And right here, we don't need the duplication of the authentication. We don't need it, and that's for it. So now let's go ahead, run our application and test it. So click on this beautiful button and we run our application. Now let's go ahead to Bruno to test the new authentication controllers. So let's go ahead. Let's change it from /product to /authentication/register for registration. Now we need to change a few things. First of all, the name is user123. The email will be email at net.sp.net, and the password will be password123. And now let's send the request right here, and we have a new user with the token. Great. So now we got it, and we also have the token in the header. So in the headers, we have the authorization token right here, as you can see. Beautiful. So right here, there we have it. Now let's go back just to test the authorization. So let's go back to the product controller and let's make it use authorization. Let's make the update. Great. And now let's test now let's first of all copy this authorization header, and let's go to the product endpoint for post, and let's remove this. This should be the price, and the product should be product for now, and price should be 1. Now let's test it. Response is 401 unauthorized. So now let's check out when we will use a new header. Let's call it authorization. So authorization header, and it will have the value of the token that we just copied. So this is in the beginning. If you just copy the token without the bear, do not forget to add the bear. And now let's send with the new body. So now we put the header. Now let's send the request. Let's send the request, and so now we have the header. Now let's run up the post request. Now that we have the authorization and the header, so let's send the request, and we got 201 created, which is confirming that our security is properly working. So This was for security. Now let's talk about test. But before we write our first test, let's answer a simple question. Why do we test software at all? Imagine you have just finished building a feature. Everything worked perfectly. But a week later, you added a completely unrelated feature. Suddenly, something that used to work doesn't. Welcome to the biggest challenge in software development. As applications grow, every change has the potential to break something else. The more feature you added, the harder it becomes to know whether your application still behaves correctly. That's exactly why testing exists. A test is simply a piece of code that verifies another piece of code behave the way you expected. Instead of manually checking every feature after you change, you allowed your computer to do it for you. Every time you make a change, your test can run in seconds and immediately tell you wherever something has broken. In other words, tests give you confidence. Confidence to refactor, confidence to add new feature, confidence to deploy your application without wondering if you have accidentally broke something important. But not all tests solve the same problem. That's why we usually divide them into different categories. Let's start with the smallest one, unit test. A unit test focused on a single piece of logic in complete isolation, usually that a single method or a single class. Dependencies such as database, API, or an external service are reloaded with mocks or fixed so the test only verify one thing, the behavior of the code itself. Unit tests are extremely fast, they easy to run, and because they are isolated, they are usually the first line of defense against bugs. But real application rarely consist of isolated methods. Eventually, your code needs to communicate with database and external API, file system, authentication service, and many other components. That's where integration test comes in. Instead of testing a single class, integration test verified that multiple components work together correctly. Can the API successfully save the data to the database? Does authentication work correctly? Can the application receive information exactly as expected? Integration tests are slower than unit tests because they interact with real infrastructure, but they provide much greater confidence that your application behaves correctly in realistic scenarios. Finally, there are end-to-end tests. These simulate computer use experience, imagining opening a browser, logging in, clicking buttons, submitting form, viewing data. Every layer of your application is involved, from the user interface to the backend, databases, and every service in between. End-to-end tests verify that entire system work as one complete application. They are incredibly valuable, but they are also the slowest, the most complex to maintain, and often the most expensive to run. Because this course focuses on backend development, our primary attention will be on unit tests and integration tests. Those are the tests backend developers write most often. They provide an excellent balance between speed, reliability, and confidence. As your project becomes larger, you will discover that testing isn't just about finding bugs. It's about designing better software. Code that easily to test is usually easier to understand, easier to maintain, and easier to extend. Testing encourages small classes, clear responsibilities, and clear architecture. In many ways, writing good tests naturally leads to writing better production code. Throughout this course, we won't treat test as something you do after finishing a project. We'll treat it as part of the development process itself, because professional software isn't considered finished simply because it's work. It's considered finished when you can prove that it's work. So, now that we understand why testing matters, let's start writing our very first one. Now you already have the knowledge to develop an application. Now you want to test that everything is working, so naturally we will go, you open Bruno, wait for the JSON response. While Bruno is fantastic for manually verifying that your endpoints work right now, relying on it as your only testing method create a massive bottleneck. Every time you change a line of code, you have to manually open Bruno, click through multiple requests, type in test data, and visually inspect the result. It is slow, prone, and human error, and completely breaks down because you cannot manually test 50 different endpoints every time you change something small. A unit test is a tiny automated script that runs in milliseconds right inside your code editor. It isolates a single function, like a specific mathematical calculation or string formatter, and instantly verified its work without needing to spin up a server or to use an external tool. While Bruno tells you if your overall API works today, unit test acts as an automated parametered safety net, instantly running hundreds of checks in the background every time you save your code to ensure that a fix in one place didn't securely break something somewhere else. So let's creating a few unit tests. We will create a few unit tests so you will understand exactly what it is. Now, unit test isn't naturally connected to our application. We will not test the API or something like that. We will test a single function in isolation, the smallest function. Maybe a function that tests that if we answer 2 and 2, the answer will be 4. So for that we will first of all need to install a few dependencies. And let's go to the terminal because before we will write the test we will need to add a few more dependencies. So .NET add package, and this will be X unit. So we will add this package. Great. Now let's add a new package. So .NET add package. This package will be MOU. Download it as well. And .NET add package. There is a few packages to download. Is BOGUS. The last two packages are mainly for mocking, which we will talk in a bit. Now we need to add a few more. .NET add package. This package will be for assertion, and it's called Fluent assertions. Let's load it as well. View. Now we need a few more. So .NET add package. Now this one came from the X unit. Runner. Visual Studio. Great. And a few more. .NET add package from Microsoft. This one is for the .NET .test .sdk, and that's all. Now let's go ahead and write our simple calculator and the test. So first of all we'll add a new directory which we will call unit test, and right here let's add a new calculator class. Now let's do all of the math operation real quick. We will have a addition, so we will use it, so we will have it. We'll have subtraction, so subtract. We'll have multiply and divide. Now there is an interesting thing with division because we cannot divide it by zeros. So if b is equal to 0, because we are dividing by b, we will throw a new divided by 0 exception because this is not possible to divide by 0. But if we don't have it, we can return a divided by b. Great, so this is our simple calculator, nothing too fancy. Now let's create our test. Calculator test. Now this is a new one. So far we know how to create methods, but creating test is a little bit different. So let's get familiar with it. So first of all we need a private read-only for the calculator, and we will assign it into a new calculator. Now for the actual test. Now .NET will not guess and set because the calculator test class has the test in it, it will say, this is a test class and let's run it. No, there is other framework that work like that, but not .NET. For running our test, we will use annotations, and the annotation for a test, we will put it over a method and it will be the fact annotation. So we will put the fact annotation, and this would tell .NET that this is a test. Now we will give it a name. Probably most of the time it will be the function name or the operation, like add or login if we are testing logging. So let's use add for now, and we will use add and what we are expecting from it. So it should return right results, because it's super simple. Now do not look over it. Now let's create the actual code. So first of all, we'll use the calculator and the function to add a few numbers. So var result, and it will be the calculator, and we will use the add method. Now for testing it, you can already see the auto completion. Try to ignore it. We'll use assertion to assert a certain value. So you can click on it. Now, why does we have the 3 and then the result? Super simple. We first of all write our so let's remove it a little bit so we will understand better. So first of all, we write the expectation, the desired result, which is 3, because 1 plus 2 equals 3. And then we put our test subject, which is the result, and it should be evaluated to 3 as well. And if they are equal, it means that our test has been passed beautifully. Great. Now, to actually run the test, go ahead to the terminal and write .NET test, and our tests will run. As you can see, once exceed test, which is this one. Now, just to show you that those are the tests that we have right here, I will duplicate it a few times. So now we have one test that succeed. Now let's write a few more tests for the other method. So fact, this will be for subtract, and it should also return the right result. Now we'll use subtract. Now we won't use 1 and 2 because it will give us a negative value. Just something like 5 and 3. Simpler to catch. Now we can assert that the result will be 2, because 5 minus 3 is equal to 2. We all know math. Now we can also test it with a few more options. So we can go right here and assert equals for 1, and we will use calculator dot subtract method, and we will use 3 and 2. 3 minus 2 creates 1. And we can do more like this. So we can change up a little bit the value to 10 and 2, and the result should be 8. We can change it into 4 and 1, and the result should be 3, etc, etc. We don't need all of those as well. So let's run the test again. So in the terminal, .NET test, and we have 2 tests succeed. Great. Now we can also test the multiplication method. Also simple. Now, if you recall, 5 times 3 is equal to 15. So let's test it. So we will assert that the result will be equal to 15. That's why we don't use auto-completion. Sometimes it's just stupid, but most of the time it's amazing. So we will assert that the result will be 15. So let's run the test again. So .NET test, and we have 3 tests succeeding. Great. Now let's talk about our divide test, because divide it's an interesting place. Let's first of all make the regular test for it. Now first of all, let's do it simply, so we won't use a decimal value. So we have 10 divided by 2, right? Which the result will be 5. Yes, hope you got me. Now we will assert that the result is not equal to 2, because I will show you the test will fail. One test is fail because the result should be 5. Now we can run it again. So .NET test. Great. So this is it. Now we have another use case that we want to test. In testing, we want to test everything. So we will test the what called the happy path, where everything goes right, and the not so happy path, which is when things will go wrong and we expect them to go wrong. Like when a user try to log in without right credentials, we expect to get an error. We don't expect that it is magically the user will be there. So we need to also take care of those stuff. So we will create the test. Now this test will be for the division. So divide by 0, and it should throw an error. So should throw exception. So now let's write the actual code. So we cannot actually keep the results right here because it will throw an error. So we need to ensure it right here. So we will assert thrown, and we first of all put the type right here, which is, as you can see, the auto completion already, divided by 0 exception, and we expect to get this by running this method. So dividing not 0 by 0, 0 by 0 is valid, 10 by 0. So now let's check out if, now let's ensure that it is correct. So this is exactly how we are going to test exceptions. So let's run this app right here, .NET test, and all of the tests are succeeding. Click this one, which means we throw an error whenever we try to divide anything by 0. So this is for the calculator. Let's also create one for strings manipulation. So it will be for string. So we can have something like capitalize. Now we'll get an input, and we first of all need to take input dot first letter, and we should substring the rest one, and that. Now we have the capitalize. We can also have multiple stuff, like now we can also have more stuff, but for now let's keep it simple. So let's create a new test for this string. So it will be string test, and we test strings very similar to how we test the calculator. So it's nothing too fancy to focus about. So it will be, let's just use private read only for the string. It will be a simple string. We will initialize it. Now let's create the test. So fact, and now void a capitalize, and should return capitalized string. So it's super easy. We just use simple assertion. So assert equals, and we will put here a capitalized like hello, and we will put here the method, so string dot capitalize, and we will put hello like that. So now let's run up the tests, and everything is working. Now let's give a few more tests for it. So what happens when we have a few letters in the middle that are not capitalized? It should do this as well. So let's run up the tests, and now we have one test failing. Right here we have hello, which means that we didn't implement the capitalize method correctly. Instead of testing it manually a few times and then catching it up, we just tell them, hey man, we just wrote one test that covers these cases, and we do this. So now let's fix it. So what we are doing right here, we taking the input, we put it into string, we make the first one into uppercase, and then we just adding the rest of the word to it from index 1 forward. Now we also need to add 2 lowercase, and now let's run the tests, and everything is working. This is the beautiful parts of tests. We find out a problem by writing a simple test, and then we can just check it out instead of doing all of this manually. Great. Now I'll show you how to test lists. So right here we will add the class which will be for to do manager. So let's add it. We will add first of all we'll add private read only list of string, and it will be all of the tasks, and we will initialize it to a new. Now let's add a few methods. So first of all, add public void add task. We will take the task and we will just add it to the list. We can have a remove task, and we can also have a string. We can have a list string to get the task. So there we have it. Now let's create the test. So to do manager test. Now we can test out a few methods at once. So to the manager, let's initialize it. Now let's use the fact annotation, fact for testing, and we will not call it test1, we'll call it add to do, and we will also test, and we will also test while we added the get to do method, because we will test one method by the other. So now let's write the test. So first of all, let's have the result, and it will be, so first of all, let's use the to do manager, and we will add a new task. We'll call it learn sp.net. Now let's get the results using, now we'll get the results using the to do dot get tasks. Now we will store it in a variable, so results b, this one, and now we will test it. Now we will start with the first assertion, assert not empty, that the list is not empty. We'll also assert that we have a single element, and we will also assert contains that we have this learn ASP.NET in the result. So this is how it is. Now let's run it. So let's run the test, and everything is working before. Now we can create this test again, but this time it will be for the remove to do. So first of all, we will test that it is there, and then we will remove the task. We'll just ensure that it is not null or empty, and next we will remove this task, and for the result we will just remove that, so it will be easier to test. So right here for the result, so results we will get, and we expect the result to be empty because we deleted. So now let's run out the tests. There should be 8 tests working and 8 tests succeeding. Now let's talk about mocks. Now, what exactly are mocks and why are we using them? Mocks are way for us to mock an operation in our test. Most of the time it is an operation that we don't actually want to happen. I'll give you a few examples. In your application, you may want to send an email when a user registers. Now, you don't actually want every time you run a test, which we will run a lot, that it will send an email to a person. It could cause all sorts of problems, and most of the time, sending an email is not connected into your application code, but to an external provider. So most of the time, the errors will not be in the application, but in the provider. And because of that, what we usually do is just create mocks. We will mock this operation. And most of the time, what we are doing with mock is just mock the behavior, so we will ensure that our application behave in a certain way. You could also mock a database call. Maybe you don't want each time you write a test to have a new record in your database. So for that, you will mock the call to the database, and you will just ensure that there was a call with a certain value to your database. So just to show you an example, let's create a mock user controller right here. So let's call it user API, let's call it, and we'll create a few methods. First one will be public, and it will be void, and it will be called register. Now we will have the username and password. Maybe it will be the email. And let's say now that we need to send a verification email to the user. So we will use the send email method. So send email method with password and email. So let's use it, and let's just log into the console. So let's just write it. We don't actually need the password, it's useless. So we just need the email. So that's all. And we will return, and only after the email, let's make the email a synchronous operation. And we must use a wait right here and make this function. So we will use the send email method, and right here, and in the end, let's return. And in the end, we will write to the console something like register successfully. Now, so this is everything. We can actually also remove the password, doesn't really matter. Now how can we exactly make mocks for it? So right here, we will go right here and create our user API test. I think API was wrong, but let's continue with that. Now let's create the test. So let's use fact and public void mock for email, and we will test it for the register user method. So that's right. Now let's implement it. So now let's go ahead and actually implement the mocks. So let's create a simple user service that we want to have. Now this user service will have a register method, and in the end you will need to send an email to verify the user. So let's write code read only, and it will be I email service that we will create in a bit called mail service, and we will initialize it in a bit. So let's create this email service right here. Yes, and it will have this send Gmail method that will get the mail, so it will get the email address, so email, and also the username. It will return the void. So now we need a constructor, so public user service, we will have the I email service, and we have that. Now let's create the register method. So register, and we will have a string for email and username. So now let's do this. Now here we can have some logic for registration. Doesn't really matter right here. What does matter is the mail service right here dot send gmail that we have. Now let's go ahead and actually test it and make a mock for the email service. So user service test, and now let's start with test. So it will be fact, then we will have public, it will be void, and we will test the register method with mock for the mail service. So now let's actually create the mock. So it will be var email service mock, and we will create it by using new mock for the email service. Now we will import it, and there we have the mock. Now we'll create a new user service with the mock email service. So now let's make the actual test. So let's use the user service dot register method, and we will register with an email of test@gmail.com, and for the username we'll have user123. And now we will use the mock, so to verify that there was a call to the email service. So we'll verify that the service with the send gmail method, that it was called with the test email, so test@gmail.com email, and with any string, so it is any of string, and it was called only once, so it was any string right here as well, is any string, so with a string, and we will ensure that it was called once. We have extra argument right here, we need to remove, and that's it. Now this is how we treat and use mocks. So let's make sure that everything is working. So .NET test, and all of our tests are running successfully. Next, and all of our tests are running beautifully and successfully. So we went over unit test. Next, let's talk about integration test. An integration test is the type of software test. An integration test is type of test that verifies whatever multiple components of our application work correctly together as one complete system. Unlike a small unit test, which focus on testing a single piece of logic in isolation, integration tests validate the interaction between different parts of the application, such as database, API, external service, authentication, and more. The goal of an integration test is to ensure that these components communicate properly and that the system behaves as expected in a real-world environment. Integration test usually runs with a few mocks and more realistic dependencies, providing higher confidence that the application will work correctly when deployed. So let's close all of those unit tests. For those tests, we need to add a few more dependencies. So let's start by adding all of those. So .NET add package, and we will add the coverlet.collector package. So we will add this dependency, and also .NET will add another package. This one comes from Microsoft and it will be a SPNet Core MVC and it will be for testing. So let's load it as well. And now, now we want to test our application with real database. So for that we need two more dependencies. So .NET add package, and this one will be for test containers. So let's load it. Next .NET add another and final package, which will be the test containers dot PostgreSQL. So let's load it. There we have all of the dependencies. Now let's create a new directory for all of our integration tests. So integration test and for our product REST endpoint. So now let's actually write the test. So let's add a new project. This one will be for the test. So let's add a new directory for testing. Now we usually will not test like that. This is just for the example. So for integration test, great. Now we will test the product controller. So product controller. So now let's create it. Now we need for the test, we need the I class fixer, and right here we'll put web application factory. So web application factory with program right here. Yes, now we need one field which will be private, read only, and will be the HTTP client, and we will add it via a constructor. So we will get it and we create the client. So this is for the setup. Now for the actual test. So fact for the test, it will be public and also asynchronous. Return task, and it will be create product endpoint, and it should create product. Now let's do this. So first of all, we will define how the request would look like. So request before the response. So the request will be a new request, and we will add name for it. The name will be, let's use I love iPhone, so it will be iPhone 18, and price will be 99.99, and this is for the request. Now let's actually make the call. So it will be await. We will use client dot post JSON asynchronous. We will post to slash API slash product, and it will be with the request. So this is for it. Now let's retrieve the response. So for response, let's save it. Now let's ensure that it was created. So how does we make the assertion that the so now let's ensure that the status code that was retrieved was correct, 201. For that we'll use assert dot equals, and we will put first of all response dot status code, and in the other end we will put the status code of created. Yes, it should be different. We expect to get created. Oopsie. Next, let's retrieve the actual product so we can ensure that we have it. So await response content, and it should be not the product but product DTO. And now we will assert that it is not null, and we will assert that the product name is iPhone 18. So assert equals for iPhone 18 to the product name. Now let's also make the assertion that the product price is 99.99, and this will be for the product price. So those are our assertion. Now let's run the code and see if everything is working. So .NET test, and so now everything is working, but the main problem is that right here, if we look at the product, we have the authorize. So let's remove it because we don't need authorization right now for the product controller. Now let's run the test again. Let's run .NET test, and all of our tests are running successfully. So back, And this test will be for the get endpoint and the delete endpoint. So it will be asynchronous as well, so it will return task, and it will be to get product, and it should just return the product. So first of all, we should go over and create a product so we can copy everything from here. So let's create a new product. Next, we will, let's just copy this. Let's change a little bit the request style so it will be simpler. So right, with this we're just creating a new one. Now we need to get the product, so we will use get from /API/product/ID, and for the ID we will use the ID of the product right here, so var product, and right here we'll use product dot content dot read from JSON as, so read from JSON async, and we will use product DTO, and in the result we expect to get the ID. So there we have it. So let's use it. Now we have the application in the product, so let's call it result. This is the result. Now let's make a few assertions. First of all, that this is not null, and the name is iPhone 18, and that the price is that. We can just copy the ones that we have right here to here. It's very similar, but the difference is that we will assert that the results will be for HTTP status code OK, and for the result code. Now we need to change it a little bit. Now there is a problem right here. Now let's actually test this. Now to test it, let's remove the product DTO, because now let's test it. So result, we will test that this is not null or empty. So not empty. We will test that this is not null and that the name is iPhone 18 as did right there, and the price is $99.99, and this is for the get test. Now let's create another fact for the delete test. So it will be a public asynchronous, so it will be a task. It will be for the delete product. So first of all, let's create a new product. So right here we will copy it. So now let's use the delete, and we will delete with that. And now let's actually check. First of all, we will need to check the results, so we need to save it in the result. So first of all, let's check out the status code. So we will assert that the status code will be equal to no content, and the result.status code as well. And we also want to check that if we are sending a get request, it will return with null. So let's copy the get request, and we want to assert that this is null. So var get product. Now we need to assert, so assert null for the product. Let's call it deleted product. So delete product. Great. So there we have it. So this is how we will create an integration test using REST. And that's the end. If you made all the way to here, congratulations. I'm very proud of you. This is a really rare milestone to get. Along the way, you have learned much more than just syntax. You have seen how to break down a problem, design solutions, structure an application, and think like a backend developer. Those skills will carry on to every project you will build from now on. But this isn't the finish line. It's the fundamental. Every great developer improves by building, experimenting, making mistakes, and building again. So don't stop here. Add new feature, refactor your code, try different approaches, and make this project your own. If this course helped you, consider leaving a like and subscribe. It helps the channel grow and allows us to keep creating more free in-depth courses for developers around the world. If you know someone who wants to become a better developer, or a business that could use a modern website or a web application, sharing this channel or our agency is one of the best ways you can support the work behind these courses. Thank you for spending time learning here. I genuinely appreciate it. Until next time, keep learning, keep building, and never stop being curious. And I will see you in the next one.